Hello everyone, how are you? Okay, today we are going to discuss a very interesting thing, that is double-ended queue implementation using inheritance. Actually, what happened? We know all the features of object-oriented programming language, but sometimes we have forgotten to apply this in our programming. So today we are just going to discuss double-ended queue, implementation of double-ended queue using the object-oriented concept inheritance. Okay, before going to coding, we are just I'm just going to give you a brief idea about what is double-ended queue and what is queue. Okay, let's start. So we know that queue is a data structure where insertion and deletion in such a way that the element which will be first inserted, that will be deleted first. Say I am going to insert the data in such a way 1, 2, 3. So insertion is done in this way. First 1 will be inserted, then 2, 3, 4, like this. So now rear here and front is here. If I am going to delete it, first 1 will be deleted and again the front will be incremented. Now front is here. Then 2 will be deleted, front will be again incremented like this. And when you want to insert another data, say I want to insert 5, so rear is now here. So this is the basic concept of the queue data structure. Now what is double-ended queue? Double-ended queue is type of data structure, type of queue where insertion and deletion is possible both of the end. Here in this case, I mean in case of queue, insertion done this direction and deletion is also done in this direction. But here in this case of double-ended queue, insertion is also possible this direction also. We know that insertion is actually possible this end, I mean this direction from here to here, but here we can also insert it in this direction. So this is insertion, and deletion is also possible from both of the end. Insertion is also possible from both of the end and deletion is also possible from both of the end. So this one is known as double-ended queue. We have two types of double-ended queue. One is input restricted and another one is output restricted double-ended queue. So from the name, I think you can understand what is input restricted double-ended queue. In case of input restricted double-ended queue, the insertion is possible from this direction, I mean if it is front, if it is rear. So the only insertion is possible here. That means first 1 will be inserted, 2, 3, 4 like this. If rear is now here, then the insertion is also possible after that like this. So this is the concept of input restricted, where insertion is possible this direction and deletion is possible. This is like a normal deletion, that from 1 will be deleted first, 2, 3 like this, and also deletion is possible this direction. That means say I want to delete 5, I want to delete 4 after that like this. Say let's take an example. Say 1, 2, 3, 4. So now rear is here, front is here. Okay, I want to delete like normal deletion, that 1 will be deleted and front will be incremented like the normal deletion. But I can also delete it from rear side. That means 4 will be deleted and rear will be decreased. This is the concept of input restricted double-ended queue, where insertion is possible only this direction. That means after 4 you can insert 5, 6, but you cannot insert one thing before 1. Not possible. And what about the output restricted? So from the name I think you can understand it, that for output restricted double-ended queue, this is a type of queue where insertion is possible from both of this side. So you can insert it this direction as well as this direction, insertion. But deletion is only possible this direction. That means say 1, 2, 3, I have this, and you can insert before 1 also. You can insert before 1 also, and then in that case the front will be decremented. But deletion is possible only this direction. First 0 will be deleted, then 1, then 2, then 3, like this. Hope you can understand. Okay, let's go for coding. Hello. So I'm going to write the code. Here the queue implementation is already there. I have written it already, and we are just going to write the double-ended queue. And we know that there are two types of double-ended queue. One is input restricted double-ended queue, and another one is output restricted double-ended queue. And so obviously there is a input restricted double-ended queue and output restricted double-ended queue. So here both of these are types of queue, isn't it? So if these are types of queue, that means we can inherit the property of queue, and obviously some modifications will be there. Okay, let's start. So I'm going to write the input restricted double-ended queue, and that's why I'm writing class in pair double-ended queue, and I'm inheriting the property of the queue. So I'm writing okay, fine. So here in this case, input restricted double-ended queue, we know that the input will be from one side and output can be both of this side. So here the is empty condition will be different, because when the front will be greater than rear, that means you are deleting it from front side and you have crossed the rear. That time also the queue will be considered as empty. So here I am going to override the function of is empty again, and here the return type of it will be boolean type. Fine. Either front equals to -1, or it will be front greater than rear. So then it will return true, else return false. Okay, so is empty is overridden. Next I am going to write the function which will be in input restricted double-ended queue. That means the output, or the originally the output is here. We can see that delete front, the deletion will be from the front side, but here the deletion is also possible from the rear side. So that's why I am writing giving the return type giving the function name. So here if is empty is true, we are not able to proceed. Is empty is empty true. So I'm just writing Cout underflow. Underflow else what will be there? The rear, from rear end it will be deleted. So here I'm writing in say I equal ARR rear, and of course the rear will be decremented when you are just deleted it, rear minus minus, and you have to return the deleted item. So I'm returning. Okay, done. Okay, so this class is written. Okay, let's check. Main. The name of the class is INPR OB dot. First I am going to insert the data. Okay, fine. 12. I'm going to insert another OB dot. Only one side of insertion is possible. This is input restricted, that's why. Okay, fine. Then OB dot display. So this insert rear is from the Q class. I mean, this is a property of Q class, and we are just inheriting the property of it. Yeah, this one is inserted. First 12 will be inserted and then 15 will be inserted. Now if we are going to delete it from the rear side, okay, let's check it. Say OB dot, we are going to delete it from the rear side, del rear, and then OB dot display. Okay, now you can see that first 12 is inserted, then 15 is inserted, and whenever you are going to delete it from the rear side, the 15 is deleted and we are getting the result. Okay, so it is worked fine. Okay, next we are going to implement the output restricted double-ended queue. Fine. This is also a kind of queue, so I am writing here inheriting the property of queue. So here the output, I mean it is output restricted, that means the output can be only be done from the front side, but the insertion is possible both of these, either it from the rear side or it from the front side. So for the rear side, this function is already written here. You can see that insert rear, the function is already written for in Q class, and we are just inheriting the Q class, that's why we are getting the property of it. And now we have to write just the insertion from the front side. Okay, insert front. Okay, better to pass an argument. If is full, else what will be written? In else part, if we want to insert the data from front side, obviously we have to do a shifting operation here, and for doing this I'm just writing it I equals to rear I greater than front greater equals to front I minus minus, and now shifting will be done. So here I am writing error rear plus 1 equals to error rear. We're just shifting one place, just shifting it, and obviously when it will be done, so from rear end the data which is there, this is a duplicate data, so we can just write that error front equals to t, the data will be inserted, and obviously the rear will be incremented. Till now the rear value is not incremented, we are just incrementing the rear value. So this is the end of this class definition. Okay, I'm just making it comment line so we can easily understand it. The class name is Deque. Okay. So ob1 dot so next we are going to write it that ob dot, say first I am writing this one 12, and then ob dot display. Okay, execute. Yeah, it's showing it. Only single data is inserted. Now I'm going to insert it on the front end. Okay, let's write it. front say 15. And again I am writing ob.display. So it's showing the result 12, 15 is, you can see that the 15 is inserted before 12. Okay, so hope you can understand, and please let me know if you can write the code in another way which will be more efficient than this code. Please let me know, comment, and okay, thank you for watching this. Bye bye.